Okay, so on this one, when you look at I is on cos, but it's supposed to be with sine there. But when you look at it, it's with cos there. So now you have to find means of removing. This is not a mistake. It's a correct question. You have to find means of removing this I from cos and taking it to sine. How do you do that? So this is simple. Let's begin. So we have on top there, we have cos theta plus I sine theta to the power 8. Then down there, yeah, so I think I've even remembered the concept which I failed to explain on this one. So I'll explain it using this same question here because I've seen it somewhere. That's why it has popped in my mind. I've remembered. Okay, so you have that on top, and then down there, you have sine theta plus I cos theta. But we know that the one which is supposed to have I is simply sine. But in this case, it's on cos. How do we move it? So look at what I'm going to do now. So I'm going to write these kinds of brackets. Follow me step by step. This is a very important concept, and the lectures at Mulungush University, they like bringing this question. Okay, so we open the bracket there, and then I'm going to write I, this I, then over I. This is just the same as 1. Yeah, so this one is just the same as 1, and then I'll open the brackets. And then from there, I'm going to have sine theta there plus I cos theta. The way it is, I'm just going to copy it the way it is. So I've not added anything to this question. If you have observed, I've not added anything. Let me just raise it to power 4 the way it is. Okay, so I've not added anything. What I mean, this I over I is simply just 1. 1 times this, I'll go back to the same expression there. So we're going to have cos theta there. Then we have plus I sine theta, then raised to power 8. And then everything divided by, so everything divided by this I'll raise it to the power 4. And then this I can go inside the brackets there because it will also be raised to the power 4. Yeah, so I'm going to have I to the power 4 outside, and then open brackets. I'm going to have sine theta over I. In other words, I've just multiplied this I throughout the brackets there. Then when I multiply this I times I over cos, times I cos theta, I'm just going to have cos theta there. I'm going to have plus cos theta, and then I'm going to raise this to the power 4. So I've distributed this 4 on both I over I and sine theta plus I cos theta. So from there, we can now write cos theta plus I sine theta. Then everything to the power 8. And then down there, we remain with, so I to the power 4. I to the power 4, remember those that I began with complex numbers. You remember I said I times I, the answer is simply just -1. So when you say I to the power 4, the I to the power 4, the answer will just be -1 times -1, which will give you just 1. So you get 1. So I to the power 4 will give us 1. So we write 1 there. There's no problem. If you want, you can leave it or write it. It doesn't matter. So sine theta over I. So sine theta over I is simply just the same as -I sine theta. I'll show you how it's coming to -I sine theta. And then we have plus cos theta to the power 4. So we have managed to bring this I on sine. We have removed it from cos, and it is now on sine, though it's negative. So we also need to make it positive. This is the point where I said I'm going to explain this point, or the point I failed to explain on this question there. I'm going to explain it on this one here, on this question. on part B. All right, so from there, we can multiply this one times everything there, which will just be everything there. So on top there, we still have cos theta, then plus I sine theta, then everything raised to the power 8, then divided by, so I can rearrange this, meaning we're going to have cos theta there, then we have minus I sine theta. And then this has been raised to power 4. Okay, so on top, we still have the same thing. So we have cos theta plus I sine theta, and then everything divided by. Now, let us push this negative inside the brackets there inside. So this is just the same as cos negative theta, and then plus I sine negative theta. So when you look at the rules of mathematics in trigonometry, let me explain it this way. When you look at, let me write this properly. Okay, so when you look at the rules of trig in mathematics, you discover that when we say cos 60, so cos 60 is just the same as cos negative 60. When you use a calculator or anything, any mathematical table, you discover that this statement is true. So cos 60 or cos any number, so cos theta in short, cos theta is just the same as cos negative theta. That's the way it is. But when it comes to sine, sine is different, is somehow the opposite of cos. So it's okay, for sine, when we say, for instance, sine, when we have sine 60, this one, when we have sine negative 60, the answer will also be negative sine 60. So negative, sine negative 60 is just the same as negative sine 60, which implies that on top, let me start with cos. So for cos, when we say cos theta is exactly equal to cos negative theta. You can try this using any number on theta there, you find the same answer. So you can also try sine negative any number there, any angle. This one is exactly the same as negative sine theta. So this is what I'm trying to talk about. This is what I was just trying to, this is the point I wanted to raise in short. So you have to know this. So this is why we're saying if we push this negative inside the brackets there, for sine, it's normal because we know that the negative of sine is just the same as sine negative answer. But for cos, it will become abnormal because when we push this negative inside there, it will be cos negative theta. But we know that even if we write a negative in front of theta, the answer will still be positive. Even if we add a negative in front of 60, the answer will still be positive 60. So for cos, it's also okay to write it this way. Okay, I hope you've gotten the point. Now I've said a lot of things. Okay, so from there, we can now, on top there, we have to the power 8, and then down there, we have to the power 4. So we can raise this negative, we can remove this negative outside, meaning the 4 there will become negative. So you have cos theta plus I sine theta raised to the power 8, and then everything divided by cos theta, and then we have plus I sine theta to the power negative 4. To the power negative 4. So from there, we can now find the final answer. So the final answer will therefore be, so the final answer will therefore be we just, since the denominator is the same, we can just add the powers there. So the final answer will be cos theta plus I sine theta. And then when we, since we're dividing, it means that we're going to subtract the powers. So when we say 8 minus -4, the answer will simply just be 12. So this is the final answer. If you want, you can go further by simplifying it and say, if you want, you can simplify it further, which is even better. So this 12 can be multiplied with the thetas inside there. So you have the final answer becoming cos 12 theta plus I sine 12 theta. So this is the final answer. Sorry for that. So this is the final answer. Yeah. So I also wanted us to do the second part, but since I've explained this trick part in the second part, where you just push the negative inside, means that it has also become simple. Yeah. And the reason why we push it in, I think I've explained. If you have not gotten the point, you have to come and play back the video and I send it to the group. Okay. So let's quickly move on. So I've explained even on this one, on the nth roots. So I said to find if you've been given z is equal to r, open brackets, then you have cos theta plus I sine theta to the power any rational root, which is a fraction in short. Let me do this, sorry. This, meaning this, if for instance, okay, let me just use n not 2 then, 1 over n. So you have to find z subscript k is equal to, yeah, so using the Moivres, this will become r to the power 1 over n, open brackets. Then you have cos, then the theta there, you add it to, if you're using radians, you say 2 pi k over n, then plus I sine theta plus 2 pi k over n. This is what you're going to have, where k is equal to 0, 1. So k is equal to 0, then 1, you have 0, 1, 2, up to n minus 1. Sum applies, okay, this is just the same thing when you're using, if the angle is not in radians, if it's in degrees, you do the same. So you still have the same magnitude there raised to the power 1 to the power n, or 1 over n, and then open brackets, you have cos, and theta plus 2 pi in degrees is simply just 360 times k over n, and then plus I sine theta plus 360 k over n. So this is what you do if you've been given a question which is in this format. Okay, let's look at some examples. Okay, this is what I was just explaining. So the k values, they range from 0 up to n minus 1. Yeah, so if you've been given, if the power there is maybe 1 over 4, if the power here, 1 over n is 1 over 4, it means that the k values will be k is equal to 0, 1, 2, 3. You end at 3 because 4 minus 1, the answer is 3, so you end at 3. If it's 1 over 3, means that the k values will be 0, 1, 2. It's 1 over 2, the k values are going to be 0 and 1. Yeah, so this is what it means. Okay, so let's quickly do maybe 1 or 2 questions, then we move on. So I'll start with question 10 before we go to question 11. So after doing these two questions, it means that we're done with complex numbers. There's nothing else apart from this on complex numbers. Yeah, so for this question, we have this question which says, find all the indicated roots expressing the results in the form x plus iy unless tables would be needed to do so. Okay, so we have 1 plus I to the power, I root 3. So we say let z be equal to 1 plus I root 3. And then they are saying we find the square root of that. So the square root of that is simply just, the square root of that is simply just, so we say z is equal to the square root of 1 plus I root 3. So the square root of this is simply just the same as 1 plus I root 3, and then everything to the power half. So square root is just the same as that. So if we have that, it means that we can find, so in this case, it means that the value of n is equal to 2. But the value of k, the values of k's will simply just be 0, and 1, because 2 minus 1, the answer is 1. So the values of k will be 0 and 1. And then we also need to convert this complex number to polar form. So how do we do that? So we first have to find the magnitude of z. So this one is z to the power half, which is just the same as that. Okay, so the magnitude of z there is simply just the square root of 1 squared plus, so the square root of 1 squared plus the root of 3 squared, which gives us the square root of 1 plus 3, which is just the square root of 4, which gives us 2. So the magnitude is 2, and then the angle, let's find the argument of z. So the argument of z will also just be equal to tan inverse of the root of 3 over 1, which is just the same as tan inverse of the root of 3. So the tan inverse of the root of 3 is simply just 60 degrees. So when you plot this complex number, it's in the first quadrant, because we know that the real part there, this is the real axis, and then we have the imaginary axis. So the real part is 1, is positive 1, so positive 1 can be there. The imaginary part is the root of 3. The root of 3 is also positive. So this complex number is in the first quadrant. So since it's in the first quadrant, meaning we take 60 as our argument. If it was in the second quadrant, we would have said 180 minus 60. If it's in the third, we would have said 180 plus 60. Yeah, so it's in the first, so we're just going to get 60 degrees. So let us now write this complex number in polar form, and then we begin to find the roots. So the complex number will now just be equal to z is equal to, this will be equal to, they said the square root of that. So the square root of z, we found that this is just the same as our R we found was 2, then open brackets, we have cos 60 degrees, then plus I sine 60 degrees. Then this is what we have. So we said the square root of z is simply just the same as 1 over 2 to the power that. So here we said the value of n is simply just 2, and then the values of k will therefore be equal to 0 and 1. So we now have to find z0. So z0 is now going to be equal to, so we are going to raise this 2, the magnitude 2 to the power half, which is just the same as the square root of 2. So when you say 2 to the power half, this one is just the same as the square root of 2. So I'll just be using square root of 2 instead of writing 2 to the power half. So square root of 2 and then open brackets. Then we have cos 60. We'll not just write cos 60. We first have to say cos Remember the formula, we said theta plus the angle in this case, the angle is in degrees. So say theta plus 360k over n. So our theta is simply just 60 and then plus 360 degrees times k. The first k value is 0. So we have 0 there. Then everything divided by n. The value of n is 2 in this case. And then we say plus I. You repeat the same. We have sine 60 plus 360. The value of k is 0. Then everything divided by 2. Yeah, so this is what we have. So to simplify this complex number, I'm going to have the square root of 2 there. Then open brackets, we have cos. Then 360 times 0 is simply 0. 0 plus 60. 60 divided by 2, the answer is 30. So we have plus I. And then sine, we have sine. Then we have 30 again this side when you simplify. Hope you're able to see what I'm writing that side. So this is our first complex number, which is Z0. Let us also find Z1 because we have 2 values of K. If we had 3 values of K, we would have also found Z2. If we had 4, Z3, if we had 5, Z4. So you can find even up to Z7, depending with the power that you've been given. I mean, the value of n that you've been given. Okay, so you have Z0, and then we find Z1. So Z1, the magnitude will still be the same. The magnitude doesn't change, it will be 2, because we also raise this 2 to the power n. What will just be changing is the angle. So the angle there will also be cos. We still have 60 there, but in this case, the value of k will be 1. So we have 360 and then 1 there, then everything divided by 2, then plus I sine. We have 60 plus 360. We have 1 there, everything divided by 2. So this is equal to, when you simplify this, 360 plus 60, the answer should give you something like 420. Yeah, it should be 420. 420 divided by 2, that gives you something like a 210. So we have the square root of 2, then open brackets, we have cos 210, and then plus I sine 210. So this is Z1. So if this was the question that you've been asked, the answers that you're supposed to find are supposed to be 2. This one and this one are the answers. Then you are done. The cube root of this one, it means that you are raising this to the power 3. So since you just have 27i, this shouldn't even be a problem. You also just have to find the magnitude of this complex number, which you find to be 27, and then the angle, which is the argument of this complex number, which will be 90 degrees. And then after finding that 90 degrees, the values of k will be, since it's a cube, so cube root is just the same as 1/3. So the values of k, n first there, I'll find n. So n will be 3. Then the values of k will be 0, 1, and 2. This is what will happen. This one, cube root, you do the same thing I've done here. The values, the value of n is 3. The values of k will be that. But of course, convert this complex number to polar form. After converting that to polar form, you write it in this format, and then you begin to put in the values there. The values of k and the angles there. This one only has the real part. You also have to do the same. Okay. This one, the fifth root, the fifth root is just the same as 1/5, meaning the value of n will be 5. The values of k will start from 0, 1, 2, 3, and 4. You end up to 4, since we're finding the fifth root. Sixth root, you end up to 5, the values of k. Otherwise, you follow the same procedure. Okay. So let's move on to question 11. Question 11, solve the equations below and hence show the solutions of these equations on the Argand diagram. Okay, so I'll start with this same question here, the first one. So we have z to the power 4. When I take this negative I to the other side of the equal sign, this will be 0 plus I. So when I want to get rid of this 4 on the left-hand side, it means that I have to find the fourth root of z to the power 4. And this side, I'll also find the fourth root of 0 plus I. So this implies that I'm going to have my z to be equal to, so my z will simply just be equal to the fourth root of, or rather, let me just say the fourth root. We know that fourth root is just the same as 1 over 4 to the power 1 over 4. So we have 0 plus I there to the power 1 over 4. So we convert this to polar form. So when you're converting this to polar form, we first find the argument and what is the absolute value, which is which is just the magnitude. So the magnitude of z will simply just be the square root of 1, which is just 1. And then to find the argument of z, so the argument of z will simply just be tan inverse of our imaginary part is 1, the real part is 0. So this one gives us undefined. So tan inverse of undefined is simply just 90 degrees. So we have the argument to be 190. The argument is, the argument is simply just 90 degrees. That's the argument. And then from there, what we can do now is we write this complex number in polar form. So we have z is simply just equal to the magnitude we said is 1, so it's just the same as not writing it. So we have cos 90 plus I sine 90. Then we put that in brackets, raised to power 1 over 4. So the value of n is simply just equal to, the value of n is 4, which is just there. And then the k values are simply 0, 1, 2, 3. Yeah, so from there we can now find z0. So z0 will simply just be 90 divided by 4. So 90 divided by 4, that gives us 22.5, something like, 22.5. So 90 divided by 4. So 90 divided by 4 is 22.5. Okay, so just here, before we even proceed, let me also show you the other way you can write a complex number in polar form, but not using cos and sine. So if you want to write a complex number in polar form, you can just write the magnitude, which is r here, then you say the angle, which is the angle. So you can write it in this format in short. Z is equal to r, and then theta there. So in this case, if I want to write this in polar form, this is just the same as my r there is 1. Okay, this one doesn't have r, so it would be somehow difficult. Anyway, let me just write 1 there. So it will be 1 there, and then the angle is 90 degrees. So you put 90 degrees, and then you raise this to the power 1 over 4. So if I want to write this, the next complex number, which is z0. So z0 is simply just cos 90 plus 360 times 0 is just 0 plus 90, it's 90. 90 divided by 4, the answer is simply just 22.5. So this can be written as cos 22.5 plus I sine 22.5. So which can also be written as 1, the magnitude is 1, the angle is 22.5 degrees. So the other Z, which is Z1, so Z1 will simply just be 360. So Z1 will simply just be 360 plus, or 360 times 1. So the first value of K will be 1. So 360 times 1 is 360 plus 90. So 360 plus 90, that's 450. Then divide by the value of N, which is, I'm following the formula that I showed you. So divide by N, which is 4. So when you divide that by 4, the answer will be 112.5. So that would be 112.5. So we have 112.5. Okay, let me write it properly. Yeah, so there was a demarcation here. So we have, and the magnitude is still 1, and then we have the angle 112.5. Let us also find Z2. The reason why I'm writing this, I don't want to consume a lot of space. So let me write the Z2. I want to leave the space to draw the Argand diagram. So we have Z2. So Z2 will now just be equal to, so Z2 for Z2, Z0, Z1, Z2, we say 360 times 2, which gives us 720. So 720, you add it to 90. The answer will be 810. So 810, you divide that by 4, which is 202.5. So we have the magnitude there doesn't change, and then you have the angle 202.5 degrees. So we now find the other Z, which is Z3. So Z3, the magnitude will be the same. The angle will be 360 times 3. Is it Z3? Z0, Z1, Z2, Z3. Okay, 360 times 3. So when you multiply that times 3, you get 1080. Then you add it to 90, which is 1170. Divide it by 4, you get 292.5. So you get 292.5 degrees. So from there, we can now draw the Argand diagram. Since we have managed to find all the Z values, we have Z0, Z1, Z2, and Z3. So now let us draw this on the Argand diagram. So we draw this on the Argand diagram. So we're going to have our Argand diagram like that. Then we have 0 there. Then we can now start putting our Z0, Z1. So I'm going to draw a circle of radius equivalent to the magnitude of these complex numbers. So the magnitude here is simply just 1. For the main complex number, the magnitude is 1, which is equivalent to the magnitude of Z0, Z1, and Z2 and Z3. So the magnitudes are simply just 1. So I can even write a 1 there. I have -1 there. I have -1 there. I have 1. Then from there, we can start putting in the complex numbers. So Z0 is simply just the angle for Z0 is 22.5. So 22.5, let me approximate it to be there, but it's advisable to use what's this? Use a protractor. You can use a protractor if you want to be accurate and neat. So you have Z, so this is my Z0, so 22.5. Then from there, I have Z1, which is 112 0.5, which is in the second quadrant, 112.5. So to make my work easy, I'm going to subtract 22.5 from 112.5. And that gives 90. So I'm going to draw a 90 degrees. If I have a protractor, it will even become easier for me to draw. So I'm going to draw a 90 degrees angle from 22.5. So my Z1 will be there. So this angle in between there is a right angle, which is just a 90 there. So from there, this is my Z1. Let us also put Z2. So Z2 is simply just 202.5. So 202.5, I'm going to say 202.5 minus 112.5. And then that will also give me a 90 degrees. So I'm also going to draw another line there. Oh, sorry, it doesn't have to go beyond the magnitude there. So I'm also going to draw another line there. So this is my Z1. And then this angle has also given me 90. And then apart from that, I'll also draw the Z3. So this is Z2, sorry. Z3 will also be the same. We subtract 202. So 202.5 minus, 292.5. 292.5 minus 202.5, the answer will still be 90. So time is even almost up. So this is what we're going to have there. So this is our Z3. So make sure that the angles between these complex numbers, Z1, Z2, and Z3 are all 90 degrees. It's not always that they are 90 degrees. In other words, let me just say, they are all supposed to be the same. They are not supposed to be different. Okay, there's a question. Since we don't use calculators, how can you be accurate when dividing? Dividing what? The divisions here are simple and straightforward. Any division that has a 0.5 at the end, it means that it's simple. It means that this is just 22.5, which can also be written as 22/1/2. Yeah, so that's how it is. They are all straightforward. So the same way of solved